Hello friends, in today's question, the following 4 wires are made of same material. Which of these will have the largest extension when the same tension is applied? So we have these 4 wires A, B and C, D, and they have a different combination of length and diameter, and we have to find out what will be the largest extension when the same amount of tension is being applied. So we are going to use, you can say, the relationship from Young's modulus. Okay. You can say using a relation from Young's modulus and which states that the extension of the wire under the given tension is directly proportional to the length and inversely proportional to the square root of the diameter. Okay. So this states that the extension is represented as delta L of the wire under tension is given by and the formula which governs is delta L is proportional to L upon D square, where L is the original length of the wire and D is the diameter of the wire. D is diameter of wire. So we are going to find out the ratio of L to D square for each of these 4 cases, and one by one then we are going to make a comparison how these ratio are going to stand with respect to each other. Calculating L by D square for each wire. So let us first of all do it for wire 1, that is A. So we have case A. Let us call this as wire 1, and L1 is 50 centimeter and D1 is our 0.5 millimeter. So we find out L1 upon D1 square is equal to 50 upon 0.5, and it is in millimeter, so we have to convert into the centimeter. So from here we can say divided by 10 whole square, so this will be coming as 50, and we have 0.5 whole square multiplied by 10 or 100 square. So this will be coming as 50 upon 0.25 into 100. So we can say our ratio for first wire L1 upon D1 square will be equal to, this will be our 200 and multiply by 100. Now this 100 factor will be common to every calculation. Okay. So we are thus keeping it 100 separate. Now we come to case B rather, wire 2 we have L2 as 100 centimeter and we have D2 as 1 millimeter. So find the ratio. L1 upon D1 square is equal to 100 divided by 1 square, and this will be equal to our 100 and the factor of 100. Now we come to case C rather. Case C, that is our wire 3. We have L3 of 200 centimeter and D3 is our 2 millimeter. So we get the ratio of, this is L2 and D2. L3 and D3 square is equal to 200 divided by 2 whole square, and this will be equal to our 50 and multiply by 100. Similarly, we cast last one, case D. Case D, which means wire 4, and we have L4 is 300 centimeter and we have diameter 4 is our 3 millimeter. Therefore ratio L4 upon D4 square is equal to 300 divided by our 3 square, and this will be approximately coming as 33.33 and multiply by 100. So if you make a comparison, we can, let me write all these values here. So first value which we got is L1 D1 square, which is our 200. I'm not writing the 100 factor because that will be common to everybody. So L1 D1 square is 200. Then we have L2 D2 square, that is our 100. We have L3 D3 square, and that is our 500. And last one is our L4 D4 square, and that comes 3.33. Okay, so bear in mind every factor is being multiplied by 100. So if you make a comparison, I think this is not 500, this is 50, my mistake. So if you make a comparison, from here we can say that L1 D1 square is greater than L2 D2 square is greater than L3 D3 square is greater than L4 D4 square. So this is a value. Okay. So the largest ratio coming is 200. So we can say that the largest extension thus the largest extension delta L, which is proportional to L upon D square, is for case A, or we can say wire 1. And for case A, the length is our 50 centimeter and diameter is our 0.5 millimeter. So we have option A is the correct option. Therefore option A is correct. This completes the question. Thank you.